So here's your formula sheet, and here are some of the formulas. Now the first conic section I want to look at is the circle, just because the circle is the most simple out of all the conic sections. There it is. That is the formula for the circle. You guys recognize that HK? Okay, HK for conic sections is the center of the shape. It is always the center. Now the first section in your book, 4.4, has the center at the origin. And so that means for all the problems, you will not have an HK. Why? Because if the center's at the origin, that means HK is 0. 0, right? So you won't see that. Like if you guys look in the book, which I want you guys to do, you won't see HKs for section 4.4. Now, going over to parabolas. This is a goofy looking function for parabolas. You guys have never seen this one. You guys have seen standard form parabolas. You guys have seen vertex form parabolas. You guys have seen... And that's all I can think of. Now here's another one. Conic section parabola. Okay, it's the same graph. It's just written a different way. And this one is the horizontal parabola. What? What's the horizontal parabola? Okay, the vertical one is the one that you guys are used to. It goes like this. Let's see, I want a big blue marker. It goes like this. Oh, gosh, goodness. Okay, it's like that, and right there is your HK. A horizontal one will go like this.
But isn't that like not
Yes, it's not a function. You're right. So we're going to call these equations. Okay, it's not a function, but it is an equation. We can still graph it. Okay, it's not a function though. So there's your two whatchamacallit, what are they called? Parabolas. The weirdest part is the 4p that we're going to have to get used to. Notice that the vertical one has the x squared, and the horizontal has the y squared. Whichever one is the one that's being squared, that's will tell you that will tell you which way it goes. Now I like the 4p way better. This one's vertical, right? And the y-axis is vertical. So whichever one has the 4p, that tells you if it's vertical or horizontal. I think that's what I was trying to get at with this squared. See over here, the 4p is with the x. It's that way I know it's the horizontal one, because x's are horizontal. Now there's other vocabulary words in here, like the focus. The focus point is... Oh, my stuff went away. The focus point is right here. That's your focus. And then there's another thing called the directrix. And we'll talk more about that as the time comes. I just wanted to show you guys the formulas. There we go. I'm taking too long again. So there's a directrix, there's the focus, there's the directrix. They're both kind of different because one's horizontal, one's vertical, but then they're kind of the same. You see right here, we have to add the p to the k. Here we would add the p to the h. And I'm going to show you guys a graph later that will explain that a little bit more. Alright, here's your ellipse. It looks kind of similar to the circle. The difference is this one equals 1. And if we go back to the circle right here, right, go back to the circle. And if I divide this by r, here let's see. Divide by r squared, divide by r squared, divide by r squared. Guys, what is r squared divided by r squared? 1. That's a 1. So doesn't this kind of look like the ellipse now? It kind of does. The only difference is this is the same as this. Whenever the denominators are the same for a function like this, you know that it's a circle. Now look at the ellipse again. These are not the same, b squared and a squared. That tells you that it's an ellipse. And the a is always the bigger one. That's always the bigger number, always, for the ellipse. And so how does that help me? Well, if the a is underneath the y, then you know that that one's the vertical one. This is what the oh, no, I go straight down to the vertical. So here's a vertical hyperbola. What's the difference here? Between this one and this one, what's the first thing you notice?
plus sign?
Yeah, this one says minus, this one says plus. Down here, the a is still underneath the y. Up here, the a is underneath the y. Oh, so if the a is underneath the y, then you know it's the vertical version of that conic. Yes. So let me throw up the rest of them. There's your horizontal ones. Here are your vertices and your co-vertices for the ellipse. This guy right here is what we use to find the C. That's going to help us find the focus point. There's your vertice and covertice and foci. So I heard it say foci or foci for the horizontal asymptote. I'm sorry, not horizontal asymptote, the horizontal ellipse right there. And then we have our vertices, covertices. Now, hyperbolas don't really have covertices, but they make sense when you're trying to graph it, so I wanted to throw it up there. The foci, and you're at, oh yeah, here's this formula. See, it looks kind of similar like the ellipse one, but notice that this one says plus, and the ellipse one says minus. That's the difference between those two. And your asymptotes. Okay, this doesn't do you guys good at all, for me to just throw all these formulas up like this. What's more helpful is to show you guys how to remember it, how to graph them. And that's what I'm going to do next.